So on this video, I will show you how to parameterize the YXMx system, which will be, in this case, will be an XY. This picture here shows a Z-axis, but I'll be parameterizing an XY system, and then I'm gonna run a CNC program. And additional to that, I'm gonna establish a communication with a CompactLogix controller over EthernetIP, and at the end I'll start the CNC program from EthernetIP. First of all, what we have to do here is, once you get these, you're gonna get the controller like the one that's over here, that's on the scope of delivery. So first of all, what we have to do is take care of the power supply, of course. Power supply, let me see if there's a picture here. So we have to supply with power this connector over here, and also let me see if there's another picture, and this one over here, X21. So we will have to put power on X1 and X21. I'll show you right here on page 36. So there's each configuration of the terminal, the pinout. So 24 on X1.1, X1.20, X1.3 ground, and then on the X21 connector. This is for the device in general, the X1, but the X21 is the low voltage supply for the actual motor controller. So 24 or 48, depending on what you need. 21.1 and ground 21.2. Once you have that, you'll receive two cables which will be connected to these two ports, drive A and drive B. That's X-axis and Y-axis. And how we connect this, there's a pinout for the cable, which is this one. So the side on the left is the connector that goes to the motor, and the side on the right is the connector that goes into the PLC. So there's something that I want to emphasize here. So it looks pretty straightforward. A1 wide, so A1 is 24. Here X20, in this case for the first one, X22.1 is 24, X22.2 is ground here on 2, 3, 24 for logic, at 22.3, 22.4 ground. But here, this is the one that we have to pay attention to, because I can't make notes here. Well, anyways, let me see if I can at least. No. All right, this one over here, this one is the one that we have to pay attention to, because I'm not gonna need it right now, because this is just an input. I'm not gonna need it right now for commissioning. So I'm gonna leave that out. I'm not gonna connect that, which is the A5 on the connector. And that cable comes already pre-assembled. On one end, the connector is already there, and on this end you have flying leads. So leave that there on the connector. You're not gonna use it right now, but on the flying lead, you're not gonna connect it. But can H, the white cable, you're gonna connect it, and pay attention here, because here's the position number 6. But on the other side is position number 5. So be careful about that, because you can make the mistake of connecting the pink cable into 5. But it shouldn't be like that. It should be white into 5, and then 6, brown, and black 7. Okay. And you should be ready to go. If you, oh, sorry, I'm missing this one. This one I already said that this has to be power supply 24 and 0, and this one X25, you have to put the 24 volts on X25.1, and I'll show you that's the torque off input. So you can connect this one together, because this one is a power supply on X25.2, so you can connect this to X25.1 and you'll be good. when you are actually putting this equipment in the machine, on the X25.1 you will put the emergency stop or whatever you need, any safety component that you need for torque off input. And then yeah, that's everything you need. So just to start using the XY system. So let's go to Codesys. So this is Codesys. I just opened it. I'm gonna download from, well, I already downloaded, but I wanted to show you from Festo.us support downloads, and then I'm gonna look up YXMx, which is the name of the controller. I'm gonna download there's a program that was already done, which is it's called Festo Positioning Basic Library. So download that. I already have it, but just download that zip file, and then we're gonna open it on Codesys here. So I'll go to my folder and just delete the one that I used to have. So I'll delete this entire folder, and I'll keep the zip file. I'll extract it again. There. Okay. So this and within that zip file, this is the first one, the YXMx is the one that we're gonna use. So I'm gonna call that over here. So I'll go temp, then YXMx, and then I tell it to extract it into the same folder. Right. It'll take a half a minute there in that, extracting the whole project. Alright, so now we have a project tree here. So when you first open this project, you have two instances here. So the one on the top, this one, is the actual hardware. But you also have this other instance here, this other application, which is to simulate this. So here you're using virtual drives instead of actual drives, so you can simulate everything before actually getting the equipment if you want. But because I already have the equipment here ready to go, I'm going to switch to this application, so you can see that this is in bold letters because this is the one that's active. So I'm gonna switch to this one, set active application, and now this is the one that it's gonna be downloaded. So now I'm gonna set the path for communication. Usually you have nothing here, so you just add the gateway, scan network, and then you see your controller there. Set active path. Okay. Okay, so we have that. Now what else do we have to do here? Okay, we have to make sure that we have our drives here. So we have 3 drives here by default. We have the X, the Y, and the Z. I don't have a third axis, a Z axis, so I'm going to disable this device. And I'm gonna kind of forget about that one. And then if you wanna go in here and just check that you have the correct node IDs here, and this is the number of participants in the CAN open network. So this is 1, and the other one is 2. You have on the motors, on the integrated motors that are on the H gantry, there's a small rotary switch, and that should match this number. So for the x-axis it should match 1, and for the other axis it should match 2, that rotary axis. Okay. Now here I have to add a as of now. I don't know if there's going to be an update anytime soon, but as of now, if you enable the motors, they are kind of noisy. So there's a way of dealing with that problem. You can add some parameters to each of the motors. I'm gonna do that right now. So the parameters that we have to put in here are under 3210. It's the first one. We have to set it to 5,000. Okay, and then I need to add another one under the same 3210. I have to add the second one. This is 1, and then I'll add a third one, 3210, the same one, and then I'm gonna jump to the fourth one, and this is gonna be 0. Okay, and I'll do that same thing for the other motor, just to have that taken care of right now. Okay, so first one I set 5000, then add the other one, 3210. Second one, it's 1, and then add a 0, 3210. We set for the fourth one, right? And this is set to 0. Alright, so we're set there. I don't think you have to change anything here. You're good there with the baud rate. You're good there. So no, you don't have to change anything here. So now I have to configure my program to what I have on the hardware. So I go into this global variable list, which is called Gbl Config, and then here I'm gonna tell the program which axes are available. So X, Y, Z, and the value or whatever. So right now I'm just using X and Y, so I'm gonna make that 0, the Z axis, and then here you can specify which controller type you're using. In this case, this is the integrated motor that comes with the YXMx, but you could also have CMMP, CMMS, EMCA, etc. I'm gonna leave that like that. So X and Y again are the same. These don't matter to me because I have them disabled here. The motor mounting that I have is bottom, so I'm gonna make that bottom for both X and Y. E bottom. Okay. Not gonna be using that axis, but it doesn't matter because I disable it on the CAN configuration on the CAN Open Manager. I don't have to change anything here. That's fine right now. Okay, that's fine too. Okay, homing order. I'm gonna change this to 1, 1, 0, 0, 0, 0. And what this means is if I had different axes, maybe I wanted the, well, usually you want the so 1, 2. Usually you want the first axis to move on a 3D gantry. You want the Z to retract, right? So if that were the case, if I had 3 axes, I will have first retract the Z axis and then move or then home the X and Y. But in this case, I don't have a Z axis, and I could probably just move these two on 1 and 1. And what else do I have to move here? Change here. I have an H gantry. That's fine. The software limits. So the minimum software limits are fine right now, but these ones I have to change. So the strokes that I have on my gantry or the hardware right now, it's 100 on X and 160 on Y. So here I'm gonna establish. So remember, these are software limits. So here I'm gonna put 95 and 155. And then for the hardware limits, I'm gonna put 97 and 157. Okay, and let's see what else. Am I missing something here? I don't think so. Okay, I'll go back here, and then I think I can download right now. Let's try it. I'm gonna log in. Yes, I'm gonna overwrite the application that is running right now. So it's downloading. It's a large program, so it's gonna take I don't know, 40 seconds or something. Okay, here we go. It's in stop right now. I hit F5 to start it. Okay, CAN is alive. Devices are alive as well. I go to the close. I'm gonna close everything and I'm just gonna open the visualization over here. So first of all, I'm gonna try and home it and see if that works. So here it says that there's a portal, it's ready to enable. So let's see if it is ready to enable. Okay, yeah, it's enabled, so I have that feedback there. Now let's see if it homes. Yes. Okay, it home right now, and it say it home, so I can remove this bit here. All right, so we got movement, and then I go to the jogging mode, and we can see that I can move. I'm watching physically the hardware, and it is moving. Then move on X, and then I could also move point to point. So let's say move to 40 on X and 35 on Y. Start moves. Okay, so that's working to point. And let's bring it back to home. It's going to home, it's moving, it's busy, homed. Alright, so that's ready. Okay, so what's next? What's next is I'm going to make a new CNC program, and you'll see that you have already here some CNC example programs. But I'm going to create another program, and I'm just going to import a DXF file. It's pretty similar to this rectangle, but it's the other way around. So let's create a new CNC file here, CNC program, and I'll call this my CNC. My CNC. And this is going to be compile mode CMC SMC CNC ref. Okay, add, and then under double click on here, I get this option CNC import from DXF file, and then I know that I have a file on my temporary folder which is called path, and that's a DXF file. So that's my rectangle there. I import that. Okay, so I have the G code now generated by Codesys, and what I'm gonna do is I'm gonna copy the speed from another program like this one. So these are the parameters for the speed, acceleration, deceleration. So, and now just so to rearrange the lines, I'm just gonna hit, so because I have these two are the same number, so I'm just gonna hit this icon here, and it rearranges the lines. Now these DXF, it seems like the coordinates are too small, so what I'm gonna do here is, okay, it's gonna be G011. What I'm gonna do here is I'm gonna scale the program, and I'm gonna do it 30 times bigger, 30 to 60. Yeah, it should be within the software limits that I established. Gonna zoom out this so I can look at the whole picture here. All right, there we go. Okay, so that's good there. Now I created the program here, but on my global variables, I have to add that program as well. So here are my programs, the three programs that I had before: circle, path, and rectangle. And I'm gonna add the fourth one, which is gonna be my CNC ADR, my CNC, close those parentheses, and that's good. So these you can have a max of 16 here, it says, and this is 1, 2, 3, and 4. So my program is going to be number 4. All right, so I go back here, and let's run the I'm gonna log in, and it's very important that after you create the CNC program, you do a download, not an online change. Otherwise, you're not gonna be able to start it. So let's start that CNC program from the visualization right now, and if that works, we can then go to EthernetIP. So a couple of seconds here to download. Again, I did a download, not an online change, so it's gonna download everything again. So F5 to run. I go to the visualization here. Oh, wait, I had it open or close all anchors. Okay, here we go. Okay, close that. I need to home again because I downloaded everything. It's homing. Okay, homed. And then internal CNC mode. And once I put here number 4, which is the program number 4, as I mentioned before, number 4, and I get the program name here. So my CNC. If I change to 1, it should be CNC circle, I think. Oh no, it's path, but it is path because under these global variables, that's how the order is. So I'll go back here, but I'll put the number 4 again, which is my program. So now I'm gonna execute and I'm gonna watch the hardware, but you should be able to see some movement here on the visualization as well. So start. It's moving. Okay, finished. And it gives me here motion complete and IPO done. And I can start that again. And you'll see it's moving and it's busy, right? Okay, so this is working too. All right, so now let's add the EthernetIP configuration. So for the EthernetIP, we right click here, add the CCC device, and then add device, and I'm gonna add a field bus EthernetIP adapter here. And then under this Ethernet adapter, I'm gonna add a Ethernet IP. Now this is the Ethernet IP adapter. Sorry. Okay, close. And then, do I have to do something on the first one on the Ethernet? Yes, I do. I need to select the interface, and the interface that we're gonna use is the ETH0. I believe that the ETH1 is for the EtherCAT because you have 2 ports there, 2 RJ45 ports. So ETH0 is for Ethernet IP. Click OK, and these values are automatically updated. I don't have to change anything here. We're good there. Ethernet IP adapter here. Let me see if I have to change anything here. No, I don't have to change anything here. All right, so add device, and I want to have inputs and outputs, so I'll add a first module, 2 modules, so that I have the first one and I'll add a second one. Okay, and then the first module, I'm gonna call it gonna rename it actually. Where's the rename here? Or I just double click here. Okay, EIP underscore in. I'm not gonna adapt all references, no. And then I said, well, you can also do properties and then here EIP underscore out. All right, and now the in I have to change here to Word. So in this case, I want a Word input module, and I believe I don't have to change anything over here. But here I can see that I should have 16 bits there, a Word. And then for the out, I need to change this Word output module and just confirm that you have your 16 output bits there. Okay, so now we can download again. And what I'm gonna do is it's not gonna ask me for online change because this is a big change. I'm gonna have to do a full download. So meanwhile, in the meanwhile that is done, I'm gonna show you on the Logix, on the Studio 5000, how to add this. So in this case, I'm gonna add a generic module. I'm gonna delete this one that I had. Yes. So I'm gonna add a new module, and this is gonna be generic. See, Codesys must be done. I can hit F5 to start it, and this Ethernet configuration here should be green. Okay, green, and the can open is coming on alive too. So generic, okay, generic Ethernet module. Okay, so now here there are some things that we have to set here. First, of course, is the name. But you can put whatever here you want. Okay, this is gonna be of type int. All right, and then this is gonna be the input instance. Assembly instance is 1 and I have 16 bits, of course, so I configured on Codesys, and then it's gonna be 116 bits, and then the ratio is 102, and you can leave that on 0. Then the IP address of the CCX 681, I believe it's 2, right? Let's confirm that. Yes, 192.168.1.2, right? 1.2. All right, got it. And it's very important afterwards. We're still missing something. We have to disable this check mark here. Use unicast. So it has to be unchecked. We'll apply that change, and then I'm gonna download this, and we should have communications with the oh, sorry, it just opened this project, so I need to establish the communications with the PLC. Gotta do that in a minute here. Who active? Okay, and it is that guy. So I'll set the project path in a minute. Come on. Oh, it's loading. It's okay. So let me see if I can set them. Okay, I'll just download from here. Download. Okay. Everything is flashing over on that PLC. Okay, yes, and we see that we have an IO OK status there. So go to the controller tags now, and okay, let's look at the inputs here over in Codesys, and I'm going to I'm online now, but this is not updating because I'm not using those variables. So what I'm gonna do is I'm gonna change this. Always update variables enable 2, and then I have to do the same thing for the output here. Enable 2. Just download that. While that is downloaded, I can do an online change on that. While that is downloaded, I'm gonna send an output, the first byte, maybe, yeah, 255. So I'm gonna send the first byte to true, and let's see if we get that first byte inputs over here in Codesys. So I have to switch to the inputs in a minute here. Okay, inputs true. Okay, let's make sure that this is not. Okay, let's put just 2 first bits. Okay, it's working. So let's turn this back to 0. 0. Okay, now let's send the data from the Codesys here. Well, whatever, like that. Control F7 to write, and let's look at the inputs. There we go. So we have the inputs over here. All right. So let's turn this to 0. Control F7. Everything goes to 0. Okay, so this is working now. So now what? Now we do have communication over EthernetIP. Now let's create a variable to start that CNC, to execute that CNC motion. What I'm gonna do is I'm gonna create another global variable list here, object gbl, and this is gonna be gbl underscore EthernetIP or EIP. And here I'm just gonna create a variable which is called global with CNC start. And now this has to come from the input that's coming from the wait. That's coming from our EthernetIP, right? So that input is IX40.0. IX40.0. Percentage IX40.0. This is type pool. Alright. Looks about right. And I'm just gonna put a comment here. This is start bit over Ethernet IP. Okay, so we have that start bit, and now we have to link it to the actual start that's in this program on this program on Codesys. So I'm gonna create a new project just to not modify anything over here on these two programs. I'm just gonna create a new one. I'm gonna say add object PLU. This is gonna be EIP and structure text add. Okay, but I need to add this to a task. Some task. It doesn't matter. In this case, the priority is too high for what I want to do, but I'm just going to put it here just for the sake of making an example. Main motion, main program, 0, and here's the EIP. Alright, so it's going to run that now. I go into that program, and now I have to assign that variable, this one, GXCNC start. You got to assign that to a variable that is, let me try to remember. If I don't remember, let's look it up on the library manager. Here, documentations. Okay, let's open that up. And let's see here. It should be this. ST. No, wait. This one, PSTCW. Something like that. Should be GPST. Let me gonna open up another Codesys project in which I already had that variable. I can't remember the name. Okay, coming up. Okay, recent projects. What was the name of that variable? Maybe it's here. Yeah, it should be here. ST. GSTCW. Let's try that. I don't know if it's that one. Otherwise, I'll look it up on that other program. What was it? GSTCW. GSTCW. Let me get it from here. Where did we put it here? Okay, here we created a variable, and then here it is. G_STN. Okay, I wasn't too far. G_STN dot. Okay, I see what happened. Start X. This is gonna be equal to the other variable that I created here in the global variables for EthernetIP. So whenever I start, whenever this variable is active or true, it's automatically this variable is automatically gonna be catching the value from that one. So let's download that. Let's do a full download. Okay, while that is downloaded, I just want to make sure how I missed that variable. So what was the name of that again? G_STN. Okay, so it's GSTN is right here, and then underscore what? Oh, .stcw. STCW. So it's this one. Okay. anyways, what is this doing? Okay, connected now, F5, and now remember that because I did a download, I have to, of course, I have to home my system. So configuration mode, homing mode, and enable start. Okay, homed. Okay. Okay, so now I can go to internal CNC, turn that into my program 4, start it. It's running. Now I want to make sure that this is working, so what I'm gonna do is I'm gonna make this small, and I'm gonna show you here the output. So it's output, and we said that it was the first bit, right? So it should be this one. So if I hit start, the 1, I turn that to 1, enter, and we have a movement there over Ethernet IP, of course. 1. Now, if you wanted to, of course, you're gonna want to execute some other instructions, right? Like homing or jogging or whatever, or even change these programs. So if you want to look at each of those variables, like the one I was traveling to find, you can look that up here under the library manager, and then Festo positioning basic documentations, and go into this PDF file. It's already open. This one. So here you can see. So for example, the PSTCW, and then it takes me to start here, which is the one that I'm using right now. Start. So it starts an action by rising edge depending on MOP. So we have right now mode of operation is internal CNC mode, so it starts the CNC, right? But if it was in homing mode, for example, it will start a home or move point to point, whatever. And you also have the some other options here. So if I go to the next page, you have actual position. You can get also, let me see where that is, enabled, all the feedback like busy, is moving, etc. Right? So that was it. That was the example to show how to link Codesys and use it with Alan Bradley CompactLogix on over Ethernet IP. Thank you.